everybody. In this video, we're going to be talking about multiplication algorithms for other bases. So just like when we were adding and subtracting in other bases, the purpose of this lesson is to help you understand the algorithms on a really deep level because you're going to be experiencing what your students will experience when they learn base 10 multiplication for the first time. So I know that this is challenging, and especially once we get into multiplication, it can be challenging to do it in other bases, but it's worthwhile because if you think about it, this is what your students are going to be experiencing, and if you can understand how to explain it in another base, it will help you become a better teacher for explaining base 10 because you will know what it's like to be in your student's shoes. So let's start off with number line multiplication. So if we have 4 times 3 in base 6, the way that we would model this on a number line is we would say, okay, well, basically, I'm going to be counting by 4s 3 times. So if I go from 0 to 4, that's one step of going 1, 2, 3, 4. Then if I go another copy of 4, so 1, 2, 3, 4, that would be my second group of 4. Then if I go 1, 2, 3, 4, and I end up right there, that shows me that 4 times 3 in base 6 equals the number 20, or 20 base 6. And so that's how you can do number line multiplication. Another way that you could also do this same problem is you could use a thinking strategy, and you could say, well, 3 is half of 6, kind of like how 5 is half of 10. So the 3 times tables are actually pretty easy because I could think about this as 4 times 6, which in base 6 is written like a 10, and then I could divide it by 2. So 4 times 6 in base 6 would be 40, and if you split that in half, that would be 20 base 6. So that's kind of a thinking strategy for how you could solve this problem in your head without having to use the number line for it. But if you want to use the number lines, that's totally fine. And on your homework, you may also want to make like a multiplication table for whatever base you're working in, because that may make it a little bit easier. So let's use some base 6 blocks to visualize what multi-digit multiplication would look like. So if I have 2, 4, 5 base 6 times 3, I'm going to think about this as 2 of my 36 blocks, 4 of my rods, and then 5 of my units. So here's 1, 2, 3, 4, 5. Okay, so this is the number that I'm starting with, and I want to make 3 copies of it. So I'm just going to select all of this and make 3 copies. So here's 1, 2, 3 copies. And the way that the intermediate algorithm works is I just multiply each place value one at a time. So I look at this part and I say, okay, when I made 3 copies of the number 5, well, how much was that? So there's kind of 2 different ways I can think about it. One way is I could use my thinking strategy because 3 is half of 6. I could think of 5 times 3 as being 5 times 6 divided by 2, which 5 times 6 would be 50. And when I divide that by 2, if I split 5 rods in half, I'll have 2 rods and a half of a rod, which would be the number 3 in both. So I know that that's going to be 2, 3 by using that thinking strategy, but I can also verify it with these blocks, because if I look at this and I regroup these, I'm going to have enough to make 1 6 block and another 6 block. And so you can see it does equal 2, 3 when you do 5 times 3 in base 6. So that would be my first step. Then I'm going to do my second step, and I'm going to say, okay, well, what's 4 times 3 in base 6? Well, I could use that same thinking strategy and say, well, 4 times 3, would be the same as 4 times 6 divided by 2, and 4 times 6 is 40. When I split that in half, that would be 20. So I'm going to have 20 rods, which means that it would look like that. And we can verify this because if I take these rods and group them together, there's enough for 1, and here's enough for 2, And you can see that we do indeed have 2 0 rods. Then for my next place value, if I have 2 of my plates times 3, well, that 2 times 3 is just 6, which means that all of these can be regrouped together into a block. And so I will have 1 0 of the plates. And then to finish off the algorithm, I would just add it all up and I'd say, well, I have 3 units, 2 rods, 2 plates, and 1 of my big blocks. And that's what 245 times 3 in base 6 would look like. And so now I'll use a chip abacus to show how to do the standard algorithm. So for the standard algorithm, I'm going to say, okay, well, if I have 5 units and I make 3 copies of it, well, here are my 5 units, and then I made 3 copies. And when I do that, I can take groups of 6 and convert them into 6 blocks. So I'm going to take these 6 chips and I'm going to put them in my 6 block column. And then I'm also going to take these 6 and convert those into a block over here. And the way I would write this is I would put a 3 in the units column and I would put a 2 up here in the 6's column. Then I'll move on and do my next place value. So for my next place value, I have 4 rods and I'm making 3 copies of it. So when I make 3 copies of those 4 rods, that's going to equal the number 2 0, because basically like these 6 make one of the next place value and then these 6 make one of the next place value. So I have 2 0, and then I also have these 2 rods that I'm going to add on to that. So when I do 4 times 3 plus 2, that gives me the number 2 2. So I'm going to write a 2 up here and a 2 here. And that's because these 6 are going to be converted into plates, but these 2 right here will stay in the 6's column. Then I'll move on and do the next one and I'll say, okay, well, if I have 2 of the plates and I make 3 copies of them, well, that equals 6, which is 1 0. And then when I add these other 2 that I carried from the previous place value, I'm going to get 1 2. And since I don't have any of my 6 cubed place values I need to multiply, I can just go ahead and write that down. And so that would be the answer for 245 times 3 with the standard algorithm. So now let's look at what the standard algorithm would look like for a 2-digit number. So if I want to do 153 times 24, that means I'm making 2 4 copies of 153. So to figure this out, I'm just going to make 4 copies of 153, and then I'll make 2 0 copies of 153, and then add those together. So if I make 4 copies of 3, that's going to be 3 times 4, which I'm going to think about as 3 times 2 times 2. So that's the thinking strategy I'm going to use here. And I'm going to say, okay, well, 3 times 2 is 6, which is 1 0. And when I multiply that by 2, that's going to give me 2 0. So 3 times 4 equals 2 0. And again, if it's easier for you, you guys are welcome to write out a times table for base 6 or whatever base you're working in, if that makes it easier for you. Okay, so that was 3 times 4. Now I'm going to have 5 rods times 4 plus 2. So let's first figure out what 5 times 4 is. So again, I'm going to think about this as 5 times 2 times 2. So if I double the number 5, in our number system, that's 10. And in base 6, it's going to be 1 4, because this represents 6. And if you do 6 plus 4, that equals 10. So 5 times 2 in base 6 is 1 4. Then I'm going to multiply that by 2. And if I double that, 4 doubled is going to, let's see, because if I double 4, that's 8, which is 1 2, because you have a 6 and a 2. So I'll have a 2 in my ones, and then I think I'll have a 3, like that. Also, another way you could figure this one out that might be a little bit easier, because 5 is really close to 6, you could think about it as 6 minus 1 times 4, which you could distribute, and that would be 4 times 10, which is 40, minus 4, which would also give you that 3, 2. So if that's an easier way of thinking about it, you could also do it that way. Or you could use your times tables. So lots of different possibilities of how you actually figure out what the times tables are. But basically, when you do 5 times 4, that gives you 3, 2. And then when you add this 2, that will give you 3, 4. So we'll have 3, 4. And then when I make 4 copies of 1, that one's easy. That's just 4. And if I add 3 to it, that gives us 7 in our number system. But in base 6, it would look like a 1, 1. And so when you make 4 copies of 153, that gives you 1140. And then the next thing we're going to do is we're going to make 2 0 copies of 153. So we're basically going to figure out what 153 times 2, 0 is, but we're going to think about it as 153 times 2, and then we're going to multiply by 1, 0, which is 6. So when we multiply by 1, 0, we're basically going to get a 0 on the end. Just like in base 10, whenever you multiply by 10, you just put a 0 on the end of the number. So I'm going to think about it as making 2 copies of like the 3 1s and the 5 6s and the 136 plate. But I'm going to start all of my place values from this 6 column over. So basically what that looks like is I say, okay, well, if I have 3 and I make 2 copies of that, well, that's going to be the number 6, which is 1, 0. So I'm going to put a 0 here and carry a 1 up here. So then I'll do 5 times 2. So if I think about what 5 times 2 is, in our number system, that's going to be 10. And in base 6, that's going to be 1, 6, and 4 1s. And so that's what 2 copies of 5 is, but then I have to add this 1 that I carried. And so that's going to be 1, 5. So I'll write the 1 up here and put the 5 right here. And then my last step is to make 2 copies of my 1 plate, which will be 2 plates, plus the 1 plate that I carried, and that would be 3. And so that would be that number. Then I just need to add these together. So the yellow part represents making 4 copies of the number 153. The green number represents taking 2 0 copies of 153. So basically the 153 times 2 equaled 350 or 350. And then when we multiplied by 1, 0, because this is in the 6's column, not the 1's column, that put the extra 0 on the end. So if I made 4 copies and 2 0 copies, in order to make 2 4 copies, I just need to add these 2 together. So I'll have 0, 4 plus 0 is 4, 1 plus 5 is 6, so I'll put a 0 here and carry a 1. 1 plus 1 is 2, plus 3 is 5, and so our answer for 153 plus 2, 4 equals 5040 base 6, and that would be our answer. And you can also do this with the lattice method. So with the lattice method, just like when we learned it in base 10, you basically write out your first number on top of the box, then you write your second number along the side of the box, and then you multiply the row and the column together to get what goes inside each of the boxes. So for example, if I do 3 times 4, that's going to give me the number 2, 0, like we figured out earlier. Because if I do 3 times 4, I could do 3 times 2, which is 6, or 1, 0. When I multiply that by 2, that gives me 2, 0, like I figured out up here. Then if I do 5 times 4, well, I figured out right here that 5 times 4 equals 3, 2. So I can write that down. And then 1 times 4 is really easy. That's just 0, 4. And then if I do the same thing and I do 3 times 2, well, that equals 1, 0. 5 times 2 equals 1, 4, like I figured out right here. And then 1 times 2 is 0, 2. So then to find out what my answer is, I just add up along the diagonals. So 0 plus nothing is 0. 0 plus 2 is 4. And then I can add up my next column, and 1 plus 4 is 5. Plus 3 will give me 1, 2, because if I do 5 plus 1, that gets me to 6, which is the next place value. And then I have 2 more beyond that. So 5 plus 3 would give me 1, 2. And then 1, 2 plus 4 would give me 2, 0. So I'll have a 0 here and a 2 up here. Then 2 plus 1 is 3, plus 2 is 5, and 0 plus nothing is 0. And you can see that we got the exact same answer there as we did with the standard algorithm. So that's how you use the lattice method and the standard algorithm to do multi-digit multiplication. And in my opinion, one of the hardest things about this lesson is actually just figuring out the times tables. So if you want to, you may want to write out a times table for whatever base you're working in, because then you can just use that instead of using all of these thinking strategies that I showed here. But if you want to use the thinking strategies, you can use those too. It's just kind of up to you and what makes the most sense to your brain. So if you have any questions, let me know, and I hope you guys have a good day.